We are now ready to consider a layout for what we will learn in this chapter. In particular, the question we are trying to answer is which parameter that is unknown about a particular population of interest are we interested in estimating? It could be the population proportion and it could be the population mean. If we want to estimate the population proportion, we need to guarantee that certain conditions are met first before we can use a normal approximation to construct a z interval for a population proportion that is unknown. However, if it is a population mean that is unknown, we have to consider if the sample size is less than 30. If it is less than 30, then we must, as a matter of fact, require that the data comes from, or the sample data comes from a population that is approximately normal with no outliers. In which case, if those conditions are met, we must compute a t interval. However, if it turns out to be that the sample size is small, that is, the sample size is less than 30, and yet there is no evidence that the sample data could come from a normal distribution with no outliers, then we have to use non-parametric methods or the bootstrap method. In this particular class, at this level of statistics, we will not go into this part, but we will, as a matter of fact, consider this case. And then, otherwise, if at the outset, if we find that the sample size is greater than or equal to 30, we do not need to require that the data or the sample data come from a population that is approximately normal with no outliers. All we can do next is compute what? T intervals. So you might observe that it is always desirable when we are estimating the population mean that the sample size should be large. This is also true in general. All right, so just a quick reminder or summary of important definitions we have seen so far. That a confidence interval for an unknown population parameter, which could be the population mean or the population proportion, will consist of a range of possible numbers that we believe with a certain level of confidence that would contain the true but unknown value of that population parameter we're trying to estimate or find. Then the level of confidence that we've been talking about will represent the expected fraction or proportion of intervals that will contain the unknown value of the population parameter if possibly a large number of different samples is obtained. And that level of confidence is mathematically or statistically denoted by 1 minus alpha multiplied by 100%. So with that definition out of the way, let's now say that for the first part, we're going to explore the part of finding the confidence interval for a population proportion. So to begin, we go on to the next page. How do we estimate a population proportion by using a confidence interval estimate? First, we define the population and the variable of interest for which we wish to estimate the population proportion. We'll determine the sample size n. We'll also select that sample or the sampling units, and we would like, ideally, that the sample to be large enough so that the condition, this very important condition, n times p times 1 minus p, be at least 10. Remember, p is the unknown, so we usually estimate that p using the sample proportion p at. Well, if you're going to use p at, you're going to need to calculate that p at itself. Then we'll specify the level of confidence, we'll get the critical value, and we'll use all of these ingredients to construct the confidence interval estimate using the formula given here below. Well, it is one thing to read all of that to you. I think it's more instructive to carry on with an example so that you see how the steps can be illustrated. So we take the first example. Construct a 99% confidence interval for the population proportion using the given information. X equals 180 and N equals 300. First thing I like to do is to manage my space here. So I'm going to draw a line here. And then next, I'm going to focus on what this means. That is, X equals 180 and N equals 300. The N equals 300 means in order to construct a 99% confidence interval for an unknown population proportion, the information I have or the tools I have is data collected from a sample of 300 entities. Out of this 300, what we have found is that 180 out of this 300, X equals 180, out of this 300 have the desired attributes of interest. So with this, I can tell something that from this sample, I have a sample proportion, which is my point estimate, which is P at, it is X all over N, and that is 180 divided by 300, which is 0.6. So first, I have my sample proportion, otherwise called the point estimate, or if I were to use a single value to find a guess for the population proportion, this would be my best guess based on that sample. But beyond this best guess, I am interested in an interval. And I would like to construct a 99% confidence interval for this population proportion. Before I can proceed further, I need to check a condition, which we mentioned earlier. This condition that guarantees that I can use the normal approximation in the process of constructing this 99% confidence interval. So I need to check if N times P at times 1 minus P at is at least 10. So in other words, I need to find the value of N times P at times 1 minus P at. So consider N times P at times 1 minus P at. This would be N, the sample size is 300. My P at is 0.6. And 1 minus P at is 1 minus 0.6. 1 minus 0.6 on my calculator is the same thing as 0.4. If I multiply all of this together, I will get 72. Well, I have good news there. 72 is greater than 10. So since 72 is greater than 10, I am free to use the formula. So the next step, use the formula that is based on the z distribution, which is called, why it is called the z interval. And that formula is right here. So I have P at, and the next thing is the operator, plus or minus. I can write that as plus or minus. Then z of alpha over 2. And then you have the standard error of P at. So let's begin. For P at, I already have P at already, 0.6. The next thing I need is z of alpha over 2. So how do I get z of alpha over 2? Here we go. I will draw the normal distribution and I will locate a portion right in the middle since I'm constructing an interval. And this interval is a 99% confidence interval. 99% is something as 0.99. And to help me get this value, which is the value of z of alpha over 2, I need the value right here, the positive number here. That number is 2.575. And how did I find it? Just in case you are asked for something other than 90%, 95%, and 99%. So what we do is I will go to StatCrunch. So here I am in StatCrunch. I'm going to close this and I will go to Stat. I'll go to Calculators. I'll go to the normal distribution. I want between and leave your mean as 0 and 1, the standard normal distribution. I'm going to change this to 0.99. Where did I get 0.99? Just a friendly reminder that came from the confidence interval, 0.99. And then going back to StatCrunch, I have 0.99 here and I'll compute. So the value I want is this positive number, 2.575. I'm going to take it as 2.575 in this case. So for convenience. And so I have the next part, the next piece of what I need. So the next part I need is the standard error. So the standard error is given by the formula earlier, and that is the square root of p hat times 1 minus p hat all over n. So I'll go ahead and do that. Standard error of p hat is the square root of p hat 1 minus p hat all over n. This will be the square root of p hat is 0.6. 1 minus p hat, we had it earlier, it was 0.4. So there's no need to waste time doing that again. And our n is 300. So this will be the square root of 0.0008, which is equal to 0.28284. So now at this point, I have the standard error as well. So I can plug in everything into. So plug in time. So P hat is 0.6 plus or minus z of alpha over 2 is 2.575, as we saw earlier. And then standard error is 0.028284. And with that said, this is equal to 0.6 plus or minus. I'll multiply these two numbers. I'll get 0.07283199985. Well, that will be equal to get the lower bound or the lower limit, I will say 0.6 minus this value, minus the margin of error. That will give 0.527168. Whereas for the upper limit, it will be 0.6 plus the margin of error. That will give me 0.67283. Okay, so with that said, I have the 99% confidence interval for the population proportion. Otherwise, besides computing this by hand, this could also be done in StatCrunch. How? Let us see. We go to StatCrunch. I'm going to minimize this. I'll go to statistics, and I want proportion statistics. One sample, and in this case, with summary. Why is it with summary? Because I only have X and I have N. I don't have the raw individual data values, in which case I would have used with data. So in this case, it is with summary. Click on with summary, then I'm going to toggle back and forth. My X is 180, my N is 300. Okay, so I'm going to take that 180 and then 300. And then at this point, I don't want to perform a hypothesis test. That will be much later in the next chapter. I want confidence intervals for P. What level? I want 0.99. Why is that? Because the question said 99% confidence interval. And then the next thing is, I want the standard world method. And then click on compute. And you have the lower limit, the upper limit, you have the standard error, you have the sample proportion. These two answers is what I want, which to some degree of decimal places matches what I have here. So that is done. As it stands, since we find that technology provides the same answer as computing it by hand, we're going to, from here on, adopt using technology to get our confidence interval. All right, that said, we proceed to other problems in the next video.